Correlation introduction. So correlation is a measure, right? Definition, right? To measure the relationship between two variables, right? If the change in one variable affects the change in the other variable, the variables are said to be correlated. So suppose if you are getting enough rainfall, the yield will be more, right? If there is no rainfall, there is no yield will be very less. So there are two variable, rainfall is one variable and yield is another variable. So one is dependent on the other. That is what the change in one variable affects the change in the other variable. The variable are said to be correlated, right? If more things are available in the market, there is no demand for that. If it is very less, then demand will be very high, right? So these two are correlated, right? It is denoted by small r. Simply is computing a correlation coefficient r that tells how much one variable tends to change when the other one does, right? When r is 0, there is no relationship, there is no correlation, right? If r is positive, there is a trend that one variable goes up as the other one goes up. Both are going up and up, right? If x is increasing, then y is increasing, right? In the graph, x is increasing, then y is increasing. X is one variable, y is one variable, and then it is called a positive correlation. When r is negative, there is a trend that one variable goes up as the other one goes down. So x is increasing when y is decreasing, or y is increasing when x is decreasing, right? In the graph, then it is negatively correlated. With correlation, it does not have to think about the cause and effect, right? It does not matter which of the two variable is called dependent and which is called independent. If two variables swapped, the degree of correlation coefficient will be the same, right? So the sign plus minus of the correlation coefficient indicates the direction of the association, right? The magnitude of the correlation coefficient indicate the strength of the association. A correlation of r which is equal to minus 0.8 suggests a strong negative association, that is reverse trends between two variables, whereas a correlation of r is equal to 0.4 suggests a weak positive association. A correlation close to 0 suggests no linear association between two continuous variables, right? Some examples: relationship between weight and height, relationship between price and demand, relationship between rainfall and yield, right? Scatter diagram. Next, the method of graphical representation of correlation between two variables is called scatter diagram. This is one of the formations. Scatter diagram will represent the correlation between two variables in graphical method. So we are going to see types of correlation. Positive correlation: if the variables are varying in the same direction, right, going up or going down. If x increases, then y increases. If x decreases, then y increases. The same direction then means positive correlation. If the increase or decrease in one variable results the increase or decrease in the other variable, then the variables are said to be positive or direct correlation, right? This scatter diagram shows a weak positive correlation. See, between x and y, the trend shown in that y increases as x increases. Both are increasing. When x is increasing, then y is also increasing, but the points are not close to a straight line. They are not forming a straight line, right? It should be like a straight line. Then only we will say that is strong positive correlation. This is positive correlation, but this is weak positive correlation. Here r is greater than 0. Then next you see the scatter diagram shows the strong positive correlation between x and y. The points lies close to a straight line. See, it is in a straight line like y is equal to x. With y increasing as x increases, here r is equal to plus 1. It is called perfect positive correlation. The height and weight of a group, example, income and expenditure. Researchers might be interested in whether there is a relation between IQ level and students and their academic performance. Academic performance related to IQ or not, right? It would be expected that high level of IQ will be linked to high level of academic performance. That is obvious. Such a relationship indicates a high degree of positive correlation between the IQ level of student and their academic performance. Negative correlation if the variables are varying in opposite direction. If one variable increasing, other variable decreasing, then it is called negative. If the increase or decrease of one variable results a decrease or increase in other variable, then the variables are said to be negative or diverse correlation. See, now we are going to see weak negative correlation. The scatter diagram shows a weak negative correlation between x and y. The trend shown is that y decreases as x increases, but the points do not lie close to a straight line. It is not a straight line, but the relation between y and x is y decreases, x increases. This is x increases, y decreases, right? The diagram is showing, right, whatever it is. So here r is less than 0, and the next diagram, see, the points are closed in a straight line, right? When y decreasing, x increases, correct? When y decreasing, x increases. So here r is equal to -1. This is called perfect negative correlation. So example, price and demand, volume and pressure. If a company making a computer chip records a high level of defective products, they decide to invest considerable capital in improving their machines and processes. Over time, it is seen that as the investment was increased, the number of defective products declined. Therefore, there is a negative correlation between investment and defective product. So nobody wants to produce defective products, right? If you are increasing the investment, so defective should be more less, right? Investment is increasing, defective is less. That is the best one, right? That is what. No correlation. See, there is no relation between x and y. This scatter diagram shows all the points are distributed, right, randomly on the graph. There is no correlation between x and y. Here r is equal to 0. Linear and non-linear correlation. Linear correlation. The correlation between two variables is said to be linear if corresponding to a unit change in one variable, there is a constant change in the other variable over the entire range of the values. In such cases, if data are plotted on xy plane, we'll get the straight line curve, right? So non-linear correlation. The relation between two variables is said to be non-linear or curvilinear if the corresponding to a unit change in one variable, the other variable does not change at a constant rate but fluctuating rate. It is go up and down. In the previous case, it will go same constant, right? So that is why you will get xy plane, that is a straight line in xy plane, right? Here you do not get a straight line because there is a variation in the other variable, right? So linear correlation like this and non-linear like this, right? Curved, right? Curved shape. Simple correlation. The correlation between two variables is called simple correlation. Just a correlation between two variables. Any two variables, the correlation is called simple correlation. Radius and circumference of the circle. Multiple correlation. The correlation between 3 or more variables, more than 2 variables, the correlation between more than 2 variables is called multiple correlation. Only two variables means simple, then more than 2 means multiple correlation. Example, the price of cool drink, temperature, income, and the demand for the drink. So multiple correlation, right? Partial correlation, the one or more variables are kept constant and the correlation is studied between the others. It is called partial correlation. Suppose if you are the yield of a paddy is depend on manure, sand quality, rainfall, temperature, right? 4-5 things are there, all are related. So if you are keeping sand and rainfall, manure as a constant, you are considering the yield and other one, right, temperature, whatever it is, right, the fourth one, then you are considering the correlation between these two, keeping the remaining all constant, then it is called partial correlation. If we keep the price of cool drinks constant and check the correlation between temperature and demand for drink, it is a partial correlation. Then properties of correlation coefficient. The time limit of correlation coefficient is lies between the limits between the correlation coefficient lies between -1 and +1. R is lies between -1 and +1. Correlation coefficient is independent of change of the origin and scale. Two independent variables are always uncorrelated. R of ax plus b, cy plus d, which is equal to ac by mod ac, r of xy, where a, b, c, d are any number such that a not equal to 0, c not equal to 0. Thanks.